Good morning, students. Are you all ready for the class? Note down the important points which you come across during the session. Today, I have come up with a new chapter in physics, electric current. This electric current is the cause behind working of all the electrical appliances and many machines. Its specific function has brought into light many modern things which we are using in our life and made our life very comfortable. So, it's very important to know about electric current. Electricity, power and current. These are the terms related to electric current. Now let's see their meaning. Electricity is flow of energy. Power is rate of flow of energy and current is flow of charge. So there is a difference between electricity and current. Electricity is flow of energy and current is flow of charge. When we are talking about current, this precisely is of two types, static current and electric current. The static current is built up only on the surface of the materials due to friction, whereas electric current is a flow of charge and it flows throughout the circuit. This is controllable, whereas static current is uncontrollable. So it's more important to know about current. Now let's see what are the topics covered under this. Here they are: electricity, electric current, electric potential and potential difference, electromotive force, electric circuit and components, current and voltage measurements, Ohm's law and its limitations, factors affecting resistance, combination of resistors in series and parallel. So these are the contents which you are going to cover under this topic. You have learnt in your earlier classes that electric current is a flow of charge. So this arises many doubts in your mind, like which type of charge flows through an electric wire when it is connected in a circuit. Is there any evidence for the motion of the charge? If so, the motion of the charge, how does it leads to electric current? How can we measure this electric current? Where do the electrons get the energy for their motion? And in which direction they move? And the motion of the charge always leads to electric current and so on. So to put an end to this questionnaire, let's get started with the last question, that is, does motion of charge always leads to electric current? You can find the answer for this question when you compare the results of three different situations. The first one, consider a simple electric circuit in which bulb and battery are connected through a switch and insulated copper wires. Switch is an optional. So here, when the bulb and battery are connected through the copper wires, switch on the bulb. You can observe that the bulb glows. See here, the battery is connected to the bulb through insulated copper wires. So here when they are connected, the bulb glows. And the zoomed area is the electrons which are flowing in the copper wire. Now the second situation. Here, remove the battery from the circuit and connect the remaining components, that is bulb, wires and switch. You can notice that the bulb doesn't glow here since there is no source of current here. So you can understand that battery is the source of current to pass the charge from the source to the consumer, that is the bulb. See the third situation. Here in this, the copper wires are replaced with nylon wires and they are connected to battery and bulb. Then switch on the bulb. You can notice that the bulb doesn't glow here. The reason for this is, here the wires which are used are made up of nylon and they do not conduct electricity. So when they are not conducting the electricity, there is no flow of charge in the circuit. Hence, we can say that the motion of charge always leads to electric current only when the charge moves in one particular direction, which you have seen in the first situation. So you have to remember the point that the motion of the charge always leads to electric current only when the charge moves in one particular direction, which you have seen in the first situation. It is same in this, like the water particles in a river, when they flow in one direction, they form the water current. Same way, the flow of air particles also forms air current. All these are moving in the same direction. Hence, they constitute a current. It can be air current or water current. This activity also tells us the fact that the nature of the substance also plays an important role in the transfer of energy from battery to the bulb. When we are using nylon wire, it's not conducting electricity there. So here we can say that the materials which transfers energy from source to the bulb are called as conductors, and which cannot transfer energy, they are known as non-conductors. So what are conductors? All the materials which can transfer energy from source to bulb are called as conductors, and which cannot transfer, they are known as non-conductors. This arises another doubt, that how does the conductor transfer energy from source to bulb? To understand this, you should know about the theory which was proposed by Drude and Lorentz, scientists of 19th century. They proposed that conductors like metals, they contain large number of free electrons in them, and these electrons, they move rapidly, whereas the positive ions are fixed in their locations. So here these two scientists have proposed that the conductors which can conduct a charge in them, they have a large number of free electrons which can move, whereas the positive ions which are present are fixed in their locations. So this arrangement of the positive ions is called as lattice. Electrons in a conductor can move randomly in the lattice space as shown in the figure which you are going to see in the next slide. So these electrons, they can move randomly in the lattice. You can see here, when you imagine this as a copper wire, the electrons which are present here, all these are moving in different directions, like one in the upward direction, one sideways, one downwards, in different directions. The same thing you can observe the right side also. So the electrons in a lattice move randomly. Electrons in the lattice move randomly, but the number of electrons crossing the cross section of a conductor, that is when you take a particular cross section area of the conductor wire, the number of electrons which are passing from left to right are equal to the number of electrons those are passing from right to left in 1 second. So here the number of electrons passage is same from right to left and left to right. This results in the net charge to 0 when the conductor is in open circuit. This can happen when the conductor is in open circuit. Now let's see what happens to the conductor when it is. What happens to the motion of electrons when ends of conductor are connected to a battery? So here the question is that how does the motion of the electrons change when they are connected to a battery? You can find the answer here. When a conductor is connected to a battery, a uniform electric field is set up throughout the conductor. So here, when you are connecting the wires to a battery, then immediately a uniform electric field is set up. How this happens is, when you are connecting the wires to a battery, battery is made up of two different electrodes, positive and negative. It also has electrolyte in them in dry form. So here, when you are connecting the wires, these conducting wires have electrons in them. And since these electrons are negatively charged, they move towards the positively charged electrode of the battery. So here, this sets up the electric field. This field makes the electron to move towards the positive end, and hence they transfer energy from battery to the bulb. So here, when we are connecting the wires to a battery, it sets an electric field. A uniform electric field is set up throughout the conductor immediately. So when electric field is formed in the conductor, this makes the electron to move towards one direction. So all the electrons are set into an order and they move towards positive electrode. So this ordered motion of the electrons is called as electric current. What do you call the ordered motion of the electrons? It is called as electric current. You can observe in the figure here. So when this conductor is connected to a battery, all the electrons are moving towards the positive end of the battery. So when the same type of particles move in same direction, they form current, as it was formed as water current and air current. In the same way, all these electrons, when they are moving in the same direction towards the positive end, they form current there. You can see here, which I have explained. You can see here in the picture, like when the wire is connected to a battery, electrons are flowing from the negative terminal towards the positive terminal, and this charge contributes to the flow of current. So when the electrons are moving towards the positive end of the battery, this ordered motion can create a flow of current. The flow of electric charges in particular direction is called as electric current. So what do you call the flow of electric charges in a particular direction? It's called as electric current. You can also be asked in the other way, like what is electric current? Electric current is a flow of electric charges in particular direction, which you can observe when the conductor is connected in a circuit. Hence, we can define the electric current as the amount of charge crossing any cross section of the conductor in 1 second. So how can you define the electric current as? It is defined as the amount of charge, because when you are connecting a conductor to a battery, immediately electric field is set up. Due to this electric field, all the electrons move in an order. This creates current. So when a current is created, all the charged particles are moving. So here, when the charged particles are moving, that the number of charged particles that are moving can be defined as electric current. So it's defined as the amount of charge crossing any cross section of the conductor in 1 second, which can be calculated by the formula I is equal to, that is electric current denoted by the letter I, which is equal to electric charge by time interval. Electric charge is denoted by the letter capital Q and time by T. The units of electric current is amperes. We are measuring the electric current with the formula I is equal to Q by T, and its units are amperes in SI system. This can also be measured in milliamperes and microamperes. Here, the unit of electric current is named after the scientist Ampere for his service rendered towards the science. So units of electric current are amperes, milliamperes and microamperes. 1 ampere is equal to 1 coulomb of charge per 1 second, and 1 milliampere is equal to 10 to the power of minus 3 amperes, and 1 microampere denoted by the letter mu, which is equal to 10 to the power of minus 6 amperes. Remember, 1 milliampere is equal to 10 to the power of minus 3 amperes, and 1 microampere is equal to 10 to the power of minus 6 amperes. So you have seen that what is an electric current and how can we measure? Using the formula, that is I is equal to Q by T. Now, is there any device to find the electric current in a circuit? Yes, it's there. That is ammeter. So electric current can be measured using ammeter, and this ammeter should always be connected in series in a circuit. Here you can see two ammeters of variable measures. The first one can measure to 1 ampere and less than 1 ampere. The readings shown on this are 0.2, 0.4, this is 0.5, 0.6, 0.7 to 1. So in this way, using this ammeter, the measure of 1 ampere and less than 1 can also be measured. Whereas the second one can measure to 5 amperes. That is from 0 to 5 amperes. Now, the other two ammeters which are shown here are used to measure milliamperes. You can see on the ammeter also it's written DC MA. What is DC you'll be knowing later, and MA is the measure of milliamperes. This can measure up from 0 to 10 milliamperes, and the second one is from 0 to 100 milliamperes. So depending on the source which we are using, the ammeters of different measures are used in the circuits. This moves us to another question, that is, in which direction do the electrons move? We know that electrons move in one direction towards the positive terminal of the battery. And you should also know the direction of electrons in the electric field. So here, to understand this, imagine a simple electric circuit. So in an electric circuit, electron starts moving towards the positive terminal. When the electrons are moving in specific direction, they are accelerated by the electric field and move in a direction opposite to the direction of the electric field. Let's see what it is with the next. Here you can see the movement of electrons. These electrons of conductor are moving in one direction towards cathode. So here the direction of flow of electrons is towards right side, and this direction is within the conductor. But to understand the direction of electrons in a circuit, consider the flow of a single electron. Now, when a single electron is moving towards cathode, which is positively charged, the charge of electron gets nullified with the proton positively charged, and there it creates a neutral charge. As the more number of electrons gets accumulated on the electrode, the less is the positive charge, and slowly the chemical charge reduces in the battery. And when the chemical charge is reducing, electrolyte which is present in the battery, it starts separating the electrons from the cathode and sends them back. When they are sending back the electrons, they are moved towards the bulb along with some energy. So here the conventional direction of flow of electric current is in the direction of flow of positive charge. Why we should say positive charge here is, when we are separating the electron, again the cathode gains its positive charge. So here the conventional direction of the electric current is in the direction of flow of positive charge. This figure explains the flow of electron and the flow of conventional electric current. Here you can see the green line which indicates the flow of electron. This flow of electrons is from the negative terminal towards the positive terminal, whereas the flow of electrons is from the positive towards the negative. How this happens is, when negative charge is moving towards positive charge, they get nullified here and becomes neutral. So there a hole is created. As more number of electrons are moving towards the positive end, more number of holes are created. So when the chemical force is reducing here, electrolyte starts separating the electron and slowly when the electrons are separated, they move. So when they are moving, the holes are also moving. Thus, we can say that the direction of flow of current is opposite to the flow of negative charge, that is electron. So here it should be clear that the flow of electrons is towards the positive terminal within the conductor, and it is opposite to the direction of flow of electric current. Let's recap the points which you have learned today. What is electric current? Yes, it is flow of charge. Next one. Does the movement of charge always leads to electric current? No. This can be possible only when charge moves in one direction. The next one. Formula and units of electric current. What is the formula to find electric current? I is equal to Q by T, where Q stands for charge and T for time. Next, what are the units of electric current? Amperes, milliamperes and microamperes. The next one, name the device used to measure electric current. Yes, it is ammeter. And this ammeter should always be connected in series in a circuit. Remember this point. How does electric current and conventional current flow? Yes, you have seen that they flow in opposite direction. So these are the few points which we have remembered now. But after the class, go through your running notes and the textbook, then complete the worksheet. I'll meet you soon in the next class.